Yes, welcome to our daily tip on CNC training. Um, this is a part I want to show you how to program using shop turn and shop mill. It has three slots, total length of 18 millimeter with a diameter of 10 millimeter. Then it goes a depth of 2.5 millimeter. So for you to program, you need to learn this, interpret this. These are the surface finish, minimum and maximum surface finish. As you can see here, inside there's a surface finish on this floor of 63, and here there's a surface finish of also 63. And then this is a D and I, that is an undercut. You have an undercut here. We have a groove. The groove here is represented here. That is the minimum diameter is 42 and the maximum diameter is 60. Then you have the drilling on this side, which has a diameter of 7, and it goes inside by that is minus 10. That is using the shank. So I want to show you this program, how you can create this program. But in case you want to learn more of this, you can come to our center. I will guide you on how to create such a program. Yeah, on DMG model machines. So let's go to our Sinumerik and see uh, creating this program. I have done two parts. First from this phase, doing turning, grooving, threading, then slot cutting. From there, I will turn the other side. I hold this side, and then I turn this side to almost minus 38. So let's go to our program. I'll show you the program. So this is the program. Um, the header. Okay, as you can see, this is the header. I have a diameter of 80, so I'm using a stock of diameter 90, and then 1 millimeter for facing. My total length is that is 100. I can put 102 because for facing I can put minus 102, 1 millimeter for facing on each side. Then this one I can put to minus even 100. Okay, minus 100. So this is what I have. Then adding 10 millimeter on my stock for safety purposes. And then here I'm using machine. Like I said, teach pattern, but I can put here a small amount where the tool will go and change. And then maximum spindle speed for channel 4, that is master spindle is 3000. Then I accept. From there, I'll come and do facing. Facing, you just click here, turning, then stock removal. You do your facing, which you have not doing facing using this tool, OD. That is CNMG 120408. That is OD rough, the angle 80 with a tip radius of 0.8, and then the tool is left. Then I'm using millimeter per revolution, that is G95. Feed rate G95, that is for 3. Material is steel, so I'm using 150. Then there is stock for the stock material, 1 millimeter for facing. It goes to deeper minus 1.6 on X. Then it will make sure that I'm going to 0 for Z with a depth of cut is 0.25, which I can do all of it once. Okay. Then next I go to do drilling. I want to create a center drilling fixed. So here you just come to drilling, then you say drill centric. So I'm doing drilling here. You see drill centric. This cutting parameters to a minus 62. I can say this 30. That is 100 minus 38. 100 minus 38. As you can see from this. So I want to drill up to here. This is an inclusion I've done for my drilling. Then from there, I do pocket on the face. I want to do a simple pocket on the face, a square pocket of 12, 12. I can even add 15. I can say add 15 with a radius of 2. Radius of 2. Okay. So this is what I've done on this face. You can see on this face. And then from there, do my contour. This is the contour. I want to do the contour. There's a ratio you need to use for you to know that the material will not wobble. You take the maximum diameter, that's 88, it times 1.414. What is the overhang distance to ensure that it doesn't wobble? It doesn't wobble. Let's check if it will wobble or not. That is 88. 88 times 1.414. So you get 124.432, which means I'm still within the range. If I do turning without without me doing second turning on this side, or without ensuring that I'm doing small materials. So this one is will prevent what we call overhang, and there's no wobbling here because the ratio is at 8 times 1.414, which is 124. That is good. This is a tip for machinists. You need to understand this tip. So this is my contour. If I can come here, this is my contour from 24. Show you the drawing. So we have 24 here, diameter 24, with a chamfer of 1.5 from the pitch. Then I got a second minus 15 here, but you see, remember it has an undercut of DNI 76A, and this is the undercut. You see, undercut, DNI, normal, pitch, yes, you can see short or normal, pitch, and then angle. Then I go to the third one, go up one by one. So you create all the contours until you reach the final part. Okay. Then from there, you add the contour for rough turning, you add contour for residual cutting, and you add contour for finish cutting. Then from there, you do grooving. As you can see, grooving, this is the groove. The groove has been given here. Maybe if I can show you, this is the groove. It's on diameter 42. Minimum diameter 40, that is T, 60. This groove is on diameter 60. Here is diameter 60. Then 52, the distance to this point. So you need to calculate. Here it's given as 55, but how do you get this? You need to calculate. I will not tell you how to do this. You come to a center, I will show you how to do computation so that you get the actual values. Then B is the width, this is length, okay? We call it the groove bottom width. Then we go to T, angle is 30, but I'm using 15. Why? 15. This is mathematics. You will understand why I'm using 15, but here angle is 30. Then here I don't have any chamfer. No chamfer. I can add a chamfer. Let's say F1, I can add a chamfer of 0.5. If I want to improve on this, then F4, a chamfer of 0.5. Okay, like this. Then I do what? I accept. I go to second. I'm doing what we call now rotational per surface. I want to show you this slot milling. You have this slot milling. This slot milling is at angle 120, but I want to rotate this to 60. So I'll do C rotation to a new 60. Then I'll come and do slot milling with the width of 10. Where is the width of 10? This is the width of 10. Yes. Then the length is 18. Here is the 18 here. You see 18 here. It is at 90. Why? If I put 45, you'll see it's not showing well. Let me show you graphical. You see 45. So it should be 90 to be horizontal, or 0 to be horizontal. Yes. And then a depth of 2.5 minus 2.5. Where is it? It is here. 2.5. For 3, that is the maximum plane infield percentage for the either cutting parameter. And then here it is 2.5 divided by 2. Okay. Get this. Then from there, how many times? How many times am I doing it? It's on diameter. It is on diameter what? 35, is it? I'm machining on diameter 35. Where is it? This diameter. Slot is on this diameter 35, but remember it's per surface C. Then this is G19, cylindrical. Then 31. Where is that minus 31? You see, this one is minus 31. Then 120 degree. Here is 120 degree, as you can see. How many times? 3 times. And this is what we get. From there, you proceed. Then I can tell my machine, go home. This is using DMG Mori, put off transformation, any axis transformation, then stop the spindle, or I can use L711 into bracket 1, like that, or 0, or 7 or 8 into bracket 0, like this. If I take this one, you'll see now switching off the C-axis, which is same as now do this one. I can remove this one, then I'll remain that. Then from there, I can do a simulation. You'll see how it will behave. So let me do a simulation. You see how it will behave when it's cutting. So in case you want to learn more about interpreting engineering design, creating a turn mill, and also using ISO code or using shop turn, you can come to a center will guide you, will show you how to get this program. This is on side A. I want to show you on side B now. On side B. Now this is on side D. You see, this is a slot now. You see the current slots. How many? Three of them on diameter 35. At the center of that one, it has finished. Now let's go the second part on part B. On part B, here is what you see. It has these holes. The holes are 6 at the angle of 60 degree, as you can see, and then it also have an internal turning. So the header will remain here. Now I'm holding at minus 30. That is 100, 101 minus 35. I'm holding at minus almost 70, so I can hold it here at this point. Then I go to facing, because maybe I'm not done facing. I'll do facing, normal facing. From there, do a drill, because I need to have a hole already drilled with the 5. Then from there I can go to 25, 5 to 10, 15, 25, like that. But I've done shortcut way for purpose of education. But for industrial purposes, you do in steps. Or you can use U-drill. Then here, 38, using U-drill, okay? Contour, this is external contour. I'm just going, contour, I'm just going to minus 32. How do you get these values? You need to calculate these values. I'm turning from this point up to this point, somewhere here, not 38, 32. Okay? Then this is external stock removal. Then retract the tool for internal turning. Tool for internal turning. Where am I retracting it? You see here? Okay? Then I go to the contour. You see the contour for internal turning? It is from here, it goes like this. Leave this hole. This hole. This hole is here. It is here, this one. Okay? This is internal turning, contour. And then I do what we call deep hole drilling. Now, you see deep hole drilling. I can do a deep hole drilling using diameter 7. As you can see here, it's given diameter 7. It comes here. Yes? But remember, this is 90 degree. 90 degree. So, which means your drill should be 90 degree. So how do you check that a tool is 90 degree? You can come to your offset here, check the tool you're using. Is it 90 degree? I can say this tool is the one I'm using. So if I want to change, I can change to 90 degree. See? So that my tool become 90 degree. I can do that. Yes? I can come to program, can say check here, check my tool. This is 7, okay? Then I can proceed to position. What is the position? From Z0, I want to start from Z0. Why? For me to put this from Z0, then it goes to R 28.5. Where am I getting it? 57 divided by 2. Then how many? 6 of them. But an angle? 60. Accept. Then from there, I can say home the machine. Then from there, I can now do assimilation. Let's do assimilation on the second part B of it. Part B of it. Yes? Turning, that is facing, drilling, U-drill, from U-drill, external turning, then boring, from boring, that is internal turning, then you come to my U-drill. And my normal drilling, you see, this is what is putting. How do you achieve this? And remember here, you are not given this distance. How do you achieve this? So in case you want to know how to achieve this, come to a center. You'll learn how to create these programs. This is what you're supposed to produce. You see, this is what's supposed to be produced. As you can see, what we have done on phase B, this is on phase B, and this is on phase A. And this is the program. So you learn this. Come to a center, learn how to run this program. I can send you these programs where you are. Yes. If you are using these machines, yes, I can send you the programs for you to use. Yeah. But for you to reach this level, come to a center. We'll teach you how to create such programs. Yes. Come to a center. We'll teach you how to create such programs, and you can see how this is very sweet. Yeah, I like Siemens controllers. We can do a lot. This is what called shop-turn programming. Shop-turn programming. For those who are people who want to excel in Siemens controllers or Fanuc controllers or Hairs controllers, learning how to create shop-turn programs, you can come to a center. You learn this, how to create advanced programs, either using CAM or using Siemens itself that has shop turn or shop mill in it, because this is turning, as you can see, it has turning, milling, and even uh, advanced controls for C rotational variance. So you can learn this. Come to a center, will teach you how to model such features and create program from scratch without even drawing it. Yes, without even drawing it. You are just given a drawing, you use the drawing to create programs. Or in case you want to learn advanced stage where you now design and then you program, also we offer what we call advanced machines, machining and CAD-CAM. Have a lovely day.